before we get started, every event that we have, the STEM So What events, we have a LibGuide that is made for that, that's on our library webpage. We've done some really neat events. So if you can use this QR code to get there. That will show you all the previous events. It also includes today's event, where there's lots more information about this topic, but also the PowerPoint presentation that we're about to see, part of it is available on this. So if you want to, in this room, we have a giant screen and we're all pretty close, so you may not need it, but when we've been in larger rooms, we've had that so you can follow along on your device. If you want to, you can do that. Check out, there are recordings from all the previous times on there as well. All right? And with that, John Martin, you want to come introduce?
Hi, you guys. My name is John Martin. I'm one of the math instructors on campus. Rumor has it I'm the best one, but I can't back that up. So I'm here to present our speakers for this evening. A couple of project designers for the engineering firm Kimley-Horn. And I'd like for y'all to welcome Juan, Soto, and Austin Maire.
Yeah, speaking of not good math, I didn't do very good in math in my scores either. All right, so that's just to put some presentations together for you guys. And I think one of the things that kind of excites me is to teach folks kind of that the engineering world is not boring, you know. So a lot of the content you're going to see is it's not baked just for this presentation. It's actual production work that we do at, you know, the day-to-day roles me and Austin do. So this is actual work. It's not just for the presentation. So the stuff you see, you can ask us any questions about it. There's no proprietary information. You know, you can take pictures of it. Record it, ask us if you want something specifically, we might be able to give it to you. You know, it's something that we use on our day-to-day role to put some of this production work and presentation work together. So I wanted to do this presentation because I live down the road. I went to ITT originally to get my associate's degree. I kind of fell into this. The world threw me a curveball. I had a kid when I was 17. I went to Northside High School. Any steers in the room? No? All right, so I'm a Fort Worth ISD grad. I lived and grew up in this area, so I know the area very well. I'm always willing to teach, and I think this is one of the things that I'm gonna do. I was telling my boss, after I'm done doing this, I wanna teach. I wanna show young people that the engineering world is not boring, so.
Hi everyone, my name is Austin. I've been at Kimley-Horn for about a year now, and I graduated from Sam Houston State University. It's about an hour north of Houston on 45. And yeah, I got a bachelor in engineering design and minor in construction management. So it's a little bit different than what I do every day now, but Juan brought me along, just a little bit more of relatability of this stuff isn't far out of reach to know and learn within a relatively small time span, so yeah.
Yeah, so I brought Austin because I figured he would be closer to some of you guys' age. I've been doing this for 30 years almost. My son's 27. That's how I know exactly how long I've been doing this. So I brought him just so he can say, this stuff is doable. He's probably has a year, 2 years, a year under his belt, and he helped me put some of this content together that you're about to see. So with that, we can get started with the presentation. There we go. All right, hit the next. All right, so who is Kimley-Horn? Right, that's going to be kind of number one topic. What we do is it's a consultant company. We have 8,000 to 9,000 employees across the U.S. Go ahead and hit the next slide, Austin. So this is kind of a map of all of our offices across the U.S. It's a big firm. So one of the things that I wanted to do with the presentation is kind of dictate what we do as opposed to what engineers do, designers, right? We're a big part of what the engineering world does now, and it's getting really, really technical. So we need specific folks to just dabble in that industry, right? Inside this tech world where it's evolving so fast. Like the things that are happening right now, if you would have told me 10 years ago I would have said you're crazy. because it's evolving so fast, you need a group. And the group we're building there is specifically set up to help implement, test these things out, make sure they work. This is why I wanted to do this presentation, right? Because a lot of times you hear engineering, right? And you're like, oh my God, I'm gonna be doing math every day. I'm gonna be doing calculations, runs and slopes and grades. A lot of the stuff we're doing involves some of that, but you're gonna see a lot of visual today because the visual component of the engineering world is only increasing daily. That part it takes a team to keep up with because technology is changing so fast, it's really hard to keep up with. The firm itself asks us kind of to keep up with some of the industry standards on what's happening, and that's what we did with the presentation. We took a little bit of all of the things we do in our day-to-day, and we put it so we can show you guys that the engineering world's not boring, so yeah. All right, so big part of what we do, and you're gonna hear this a lot, CAD. History has always told us, like, you're a CAD guy. You do CAD, right? You do, this is exactly what engineers do and designers do. They use CAD. CAD's a computer-aided design tool that we've used for a long time. When I first got into this industry, we actually had to do a lot of it by hand. Yes, I did draw on the board by hand. Well, so when I got CAD, I was like a kid in a candy store, and I said, I'm gonna learn everything about this tool. I'm gonna be so efficient with this tool that I can do it with my eyes closed. 30 years later, I'm still doing it. Every year, they released a new tool with new functionality to be more efficient, better workflows, make it faster, streamlined. They add components to it. So for that 30 years, this tool has paid my mortgage, right? But it's really interesting to me that the tool is still the same tool. We've just added more to the repertoire now. The second tool you see up there is called Revit. Revit is a tool, it's a parametric tool, and if you understand what parametrics are, is let me put something in this place, and what happens if I change this object? What does it do to the rest of the infrastructure or the rest of the objects inside the models, right? You'll hear a lot of that today, and some of the verbiage, if you get lost a little bit, just come ask me about it at the end. I know I didn't put every definition in there, but I wanted to kind of outline some of the roles and some of the tools that we use throughout the day. So Revit's a big one we're using because we use vertical structures. CAD doesn't do very well with vertical structures. CAD is really just for plan work, geometry work. Revit's more a modeling, a visual tool. You can actually create these objects in context and actually see those things come to life in front of you. CAD's a little different than that. It's more for the geometry. ArcGIS, we use it a lot for infrastructure projects to kind of show the public and folks that are involved in those projects, either piping alignments, where the sites are gonna be, big infrastructure projects, kind of citywide infrastructure projects. We use that a lot for analytics, to kind of show the cities, what does our infrastructure water look like, compared to what you have right now, things like that. It's a big model tool. InfraWorks and Navisworks, which is right now my favorite tool. I've been using it for 10 years. This is how I get wows in the room. Sometimes engineering is difficult to make sexy, but this tool helps me make engineering world sexy. 3D visualization. The reason those tools exist, because now it's gotten a lot easier to do the 3D visualization. That's a byproduct of the models, right? Think about a house. A lot of times you see a floor plan, right? And you're like, oh, that looks pretty cool. But what if I modeled that house? You get a better perspective. Well, what if I gave you a headset now and I let you walk in that same house? How much better is that than looking at a floor plan, right? That's the same thing that's happening in the industry is we're not creating these floor plans anymore specifically for the construction. It's a byproduct of the models now. We're creating these 3D worlds so you can immerse yourself instantly. Anybody that doesn't understand construction or these construction documents is gonna understand what that model is. You know what a door looks like. You know what a window looks like. We can teach you what a pump looks like. We can teach you what a pipe in the ground looks like. And that's what these tools are starting to do. Project coordination, that's everybody in the engineering world. We all handle project coordination. Every single one of us that works, doesn't matter what company you're in, that's a big part of what we do in our daily role. All right, So this is a byproduct of CAD. This is what we make our money on at Kimley-Horn. A lot of our work comes from these big, gigantic 500-page sets that have planning profiles in them. Basically what this is that's showing an alignment of a water line, and this is telling you what's gonna look like inside the ground. We have to tell the contractor specific information about how they're gonna build that object, right? This has been bread and butter for the engineering industry. So I don't even know how long it's been. It's been years. What would you say, John? 100 years. We used to do this by hand. Then CAD came along. Now we can do it so much faster, but CAD's been static for a long time, right? It's still geometry based. You still have to learn how to draw geometry. It's basically, I can show you how to draw a line. You can basically come up with these type of plans on the construction site. All right, and then now Revit, right? Now Revit gets introduced to the world, and this is when my brain kind of like went crazy, right? It's like, holy smokes, I don't have to just draw these geometry components anymore. Now I can model in this world up here and get this. That's what excited me when I first saw it is, now I can start putting it in context. I can start modeling all of these heavy objects with really rich detail and still get this product out. And my boss is gonna be happy because he gets this, but I get to visually walk inside that over there, right? So it's a little bit of both worlds. You end up getting the construction document and you get the visual. But it's still kind of static, right? It's still one object. It's still kind of singular. So it's really just one component that's being made inside that model. All right, now GIS, right? So GIS, really we use this tool to show a lot of pipe alignments, big kind of master planning shows or production work. It's because a lot of times when we're routing these alignments, it's a big ordeal, right? When you're putting a huge pipe down a center line of a property, one, that's somebody's property. Two, you're gonna disrupt construction. Three, the contractor has to get heavy equipment out there. So we use GIS a lot to route different scenarios for all these pipe alignments that we're using. So it's a really good visual, but still it's really generic, right? It's really just a line that's draped on the terrain surface that you see to help with the visual. But we can actually start putting some of those objects in context. If you see that little area by the tank over there, that's the same pump room you saw in that Revit model, right? So it's kind of like, the way I explain to folks is kind of like Legos, right? We have this gigantic world, and then we start putting these Legos and we start stacking them depending on what we need. But depending on the tool, we get different output for the models. And here's the pump station that we did. Go ahead and hit play, Austin. This is me putting it inside InfraWorks that then allows me to start putting the terrain model together, right? The ground that it sits on. It allows me to start putting the concept of our site together. It allows me to start putting the roads that have access to this pump station. And it also allows me to get subterranean. That's the part that I like about InfraWorks. It allows me to get underneath the ground and still see a lot of the objects that are embedded in the terrain. I'll let this go a little bit. So you can see like the amount of detail that we put in. This is not line work anymore, right? This is not that black and white construction document you saw earlier, but this is a byproduct of that. We're still getting that object or that construction plan. It's just slightly different environment that we put it in. All right, so a byproduct of the model, right? What else can we do? One of the things that's happened over time is we're asking the models to give us more, right? We spent all this time and money and effort. What else are we getting from it, right? Another byproduct is the visual. This sometimes is hard for the average person to understand what's happening. But if I show you this, now you start to understand, oh, you basically cut that little room so I can see what's happening subterranean, and you have a stairwell getting down to that area, right? A lot of those visuals are because sometimes in these projects now, we have to portray what we're trying to do to the public. So the public has a lot of input on what's happening in these projects. And I'm gonna show you a project here in a little bit where we put a pump station in front of a residential housing development. Well, what if I told you I'm gonna put a big tank in front of your house? What are you gonna do? You're gonna be upset, right? I wanna see what that looks like immediately, because I wanna know who do I need to complain to if you're gonna put a big tank in front of my house. This is one of the treatment facilities that we put together. Me and Austin work on water, wastewater specifically, but we use these visuals for a lot of presentation work and a lot of construction documents. So this is a byproduct of us putting all of those Legos together, right? Once we stack all those Legos, we then can take this, because the hard work's done. We've done all the design work. We've done all of our calculations. We know what the site plan is gonna look like. All we have to do now is compile the information and start to give people that don't understand those black and white construction documents, give them this aspect, and they're like, okay, I get it now. This is what I'm spending $500 million in my city tax budget now. These have been really great for us to win work at my company. And I could tell you, it's been really efficient and really awesome for me to see this type of work get dispersed throughout the firm. Now a lot of folks are doing this because we know this will sell and this will help us win work down the line. I love this slide right here, because at some point this was me, right? This was me kind of sitting there putting ink to paper and getting my sleeves dirty. Not anymore. We don't have to do that anymore. One of the things that's changed over time in the engineering world is the communication part, right? Everything I've showed you is a byproduct of the design work we do, but now I can easily tell the story and I can easily give that information to you. Go ahead and click on the BIM documents. The communication part in the engineering world is what's changed so much, because in order for me to give something like this to you before, it was so difficult. This was, gigs of data 5-10 years ago. Now I can give you a link to a website, push the model out to this cloud service, and immediately have input from all the stakeholders in the project. My engineering team, my design team, the people that are, putting the budget together for this. They can easily go in there, select these objects, say, hey, why are we doing this? What are we doing here? What does this cost? We can easily start pulling this information. And that's the part in the engineering world that's changed so much, is now I can easily push this to a cloud service, and you can have this instantly. While Austin's over there changing it, syncing it, you're gonna get the visual updated in this cloud service. So cloud services are a really big deal everywhere, but they're really a big deal in the engineering world because we're able to share our information so much faster. Yeah, go back to okay, one thing I want you guys to do, this is interaction, right? QR codes made a comeback. I don't know how. It was 10 years ago when I first saw a QR code, but our folks love them because it's a time saver and a space saver on some of our RFPs and RFQs, which is sometimes clients request qualifications for these projects. So what we've started doing is we started embedding these QR codes to save space on those presentations and that paperwork, right? It's just a time saver and an area saver for them. So if you guys click on this QR code and scan it, it goes directly to a model. So I can put this anywhere and give you access to that same model. And that's really interesting, because before it was really difficult. We would have to render the animation. We'd have to save it to a place and then somehow share it on a website, and you guys can go either upload it to YouTube. Now it's just basically that location. That the communication part, I think over the years is the one thing that I think has changed the most in the industry, is because we have so complex projects. We have citywide sometimes projects, and sharing that information now has gotten so much easier. You can pull it up on your phone. And I think that right there is really awesome, because our engineers can pull up our models and say, okay, I can see what's wrong with that model instantly let's talk about it, let's change it. And so that communication portion is the one thing that's changed a lot of. Here's that same QR code in context. This is a space saver, right? Instead of us putting the animation in there, what we did is we compiled the QR code and put in 3 stills in this presentation and inside this RFP. So RFPs are just to kind of show our qualifications and kind of dictate what we're going to do on the project. But think about the space we just saved there for this specific task, right? All of these QR codes, all they do is go to that same model that we generated. Go ahead and click on that first one. All right, so one of the interesting things that's happened because of the models being generated is we're able to utilize these models more, all right? So AR, VR is starting to be a big player in the industry. This is me testing the headset on with one of our models, right? This is me and a colleague of mine inside one of our basins doing some testing and demoing, right? You can't tell by this video, but you're gonna see me measure this pump, how huge that pump is, or that you can't really tell if you're looking at it, but if I'm in the headset, that pump is this high. So I'm able to measure that inside the headset and also record it, right? So that dimension stays in the model and in the headset. So if I give that headset to anybody else in that same model that I gave access to, they're able to see all of that information that I leave in there. So AR and VR are starting to be a really big player in the engineering world, and I'm pushing this heavy with our guys. At some point, I'm gonna talk to our guys and say, how about you not give us a monitor and just give us a headset, right? How about, it's just an idea, you know, how about don't give us a third monitor, just let us see what a headset looks like. Because our subs and our folks that are in the industry are asking us if we're able to do this, and we have to be ready for this. This is something that I think it only benefits the model, right? There's more usages for it. What else can we do with it? Our clients are asking more. People that run these plants and these facilities, imagine if I could submerge them in the virtual world immediately without them having to even look at a construction plan. Yeah, they need to look at it because they need to know what we're designing and what they're going to be maintaining. But for me to immerse him in the headset and immediately he can walk in this basin and say, I can't reach that valve. How am I going to maintain it, right? That's what we want to do is we want to give them this virtual world so they can have access to this information. Because if we design it wrong, they can immediately tell us, hey, you need to fix that hand valve, or you need to fix this pump, it's in the wrong location, or I can't even get to that motor to work on it. So that immersive part is only increasing because we're generating these models with that really high detail. This was really fun for me because it's interesting as I'm testing these, and you guys will find this hilarious. It's interesting when I give it to a young person, and I've said this in the office, right? I've given it to one of our really young engineers, and they immediately grab the headset and the controllers, and they're going. They're walking. I don't have to explain anything to them. They're walking the site. They're tagging things. They're asking questions. I give it to a slightly older gentleman in the office, and they struggle so much. But this is why it takes a team to keep up with the technology, right? Because it's one of these things where at some point, those guys and myself are going to be moving on, right? We're going to be retiring. This is where the industry is going. This is where from CAD, from drafting to CAD, now to creating these immersive models for different purposes. All right, so another thing that we can do with these things, right? This is something that this is a company called I think it's QGIS. And what they do is they take all of the utilities that are in the ground and they project them AR and VR wise, right? So this is a geospatial environment. They're not only putting these objects in the ground, they're putting them in the ground where they're gonna be at. And so that part right there excites me a lot because right now, we manually do this placement, but these guys have figured out a way to immerse this technology subterranean-wise in the ground, right? This is really exciting because at some point, you'll be able to basically project anything in these VR worlds. Next slide. All right, so this is another one. This is the one that I was talking about earlier. We put a pump station design together, and we put it in front of some residential houses. And one of the engineers came to me and says, hey, we got a problem. It's not a problem, just an issue, right? We have eight or nine, I forget how many residents that are basically not happy that we're putting this pump station in this area. So we took our model, we rendered it in a tool, and we created this interactive space to where not only did I give them their virtual environment, I gave them a location in front of their house, right? So you can see I created this site, and this is not engineering, right? We're looking at this and like, how the heck is this engineering? Well, that tank and this pump station, that's ours. That's our design. We put that pump station together, so I need to help them sell that project. So if you got 10 people in that residence that are upset, guess what's going to happen to the project? It might not go through. So I got to figure out ways to convince them, look, we're screening it. We're making it really nice looking. Our architect is involved. They gave us the building structure and the facade. What does it mean for the tank? Well, it's going to be a little bit further back. You're going to see a big Denton logo on it. All of those things help sell the project. And yeah, it's a little bit visual, a little bit engineering, but it's really cool because now I can give that link to the public and say, if you want to actually see what we're doing, we're gonna cover this area with landscape. We're gonna put a screen wall there, so it's really, you're not gonna see the pump station that much. Yeah, you're gonna see the tank, but you're not gonna see all of that equipment in there, right? When you hear pump station, you're like, oh my God, I don't want to have pumps and motors and all of this. Really, it's really not that bad visually, right? It's more like, oh, it looks like a house, with a tank in the back. But that's the hard part of what we do. Sometimes it's difficult to sell these projects, but this type of work that we're doing now, because of the 3D world that we're generating, make this part so much easier now. All right, so one of the last things that we're testing right now is what more can we get out of our models, right? All right, we create this really cool model. We create these really cool renderings and animations. Now our client comes back to us and say, hey, that's great. You charged me $500 million. I want to be able to use that data somehow. So this is a tool called Unreal, and I'm testing this right now. One of the things that has been getting lost is when you translate these objects into these other tools, you end up losing that metadata that it pulls in, right? If my designer, if Austin's there, he's designing a pipe, and he says this pipe diameter is 8 inches, right? I shouldn't have to tell another tool that that's an 8-inch pipe, right? It should know that because our tool generated that. Well, they want to know that, and historically, that data has been lost when you translate it to these other tools. Well, this is a game engine, right? You're going to start to hear the development of game engines specifically because they're really interesting to be able to pull our data in and be able to show our client rich context and actually start quantifying this information, changing materials if they want to get different quantities, get kind of schedules to see how much equipment's in there, how much of this information that we're already embedding in these objects, how much of this can I actually use later on? Well, you can see this little chart here on the right side. You start to see all that same information. That same information doesn't get lost. That's the really cool part that we're harnessing right now is once we generate this information, it doesn't get lost, right? It's still being utilized in another tool. It's just in a different format. So we're able to put these schedules together for our client. We're able to get them costs and quantities instantly, and they get to immerse themselves in the tool. This is their model. They get to walk it pick out anything they want in there and kind of list it for themselves, and even change things, specifically in the model. And this is me in one of our sites with the headset. I wanted to show this because the size of the models is getting easier and easier to port through these tools. 5 years ago, I couldn't do this. These models were so heavy because of the rich information in them that getting them in these headsets was really difficult. But I think now as technology has improved, our skill sets improved too, and the technology is just moving along faster. Software, some of the hardware is improved. It's really easy now to push these things in and out of these tools and actually show them to folks that are making these decisions on these projects that don't necessarily understand the construction document or that CAD drawing that you saw earlier. We'll let this play out. Awesome. Here I'm just adding some dimensions in the model just so you guys can see kind of how deep that basin is. But when I first got into the headset, one of the things that amazed me, and again, I've been in the industry for a long time. Standing next to a 36-inch pipe diameter, you don't realize how big that pipe is until you immerse yourself in these models and actually see that pipe standing next to you. And all of this information is rich, so it stays in the model. It can be shared. That's the interesting thing about these models is sharing these objects now is a lot easier. So here I'm trying to figure out, is that really that high? Like, is it really 6 foot and some change high? And this model specifically came from the InfraWorks tool, so we ported it in. But you can see, this is a big area that we ported in, and I was kind of pushing the machine to try to see if it could do it, and it did it without even blinking. All right, next one. I think with that, we got one more. Oh, this is John's tank right here. This is John's elevated storage tank. So this was an interesting case because one of the engineers asked me, we were putting this elevated storage tank out in the middle of, Odessa? West Odessa. And he kind of asked me, thinking that I wouldn't be able to do it, right? He said, "Hey, Juan, is it possible for you to take the tank and actually project it onto the site in the middle of nowhere?" And I kind of took it as a challenge, right? I'm like, well, wait a minute, we have the tank, right? We have the technology. Well, I went out into our patio. This is the front of our office here in our kind of this park area that we have. And I took a tool that I downloaded and kind of learned, and I said, this is too easy. So the tank basically got set in there inside the application. Now I can send my client a link to exactly this location. He can hold the phone up and he can see that tank out in space. This is kind of, the software or the workflow doesn't even matter, right? Because you can do anything like that now. That's the thing that caught my eye. I was like, wait a minute, if I could do a tank, I could do anything. You know that Pokemon game that was really, really popular a while back? That's my Pokemon right there. Now, I went a little crazy and I started putting tanks everywhere in our park area just so I could prove to the engineer that this is possible and we can do it out there. So I look forward to doing more of this because this is kind of the stuff that excites me now. Anything that's new in the technology world, I'm always trying to see how we can utilize it and use it in the engineering world. And AR, VR is kind of this platform where I think it's untapped in the engineering world, but you can see how we can immerse ourselves in these tools fairly easily. I was talking earlier about the amount of data we can share. So what you're about to see here is a point cloud. Now, what a point cloud is you know that little laser you use to measure something? You point it at something, instantly gives you a measurement, right? When you're doing some type of, installation of, wall or something, or measuring drywall height or ceiling height or something. But what you're seeing here is that scanner there that you see there, that Faro scanner on the corner, we take out on these sites. Communicating the existing infrastructure sometimes is a big ordeal in our world, right? Because we're trying to figure out what the existing conditions are, and we deal with a lot of old facilities, a lot of old facilities. So when we look at plans from, 1920, they're really not up to date, and they're really, really terrible. And because they were drawn by hand, a lot of the information is missing. So one of the things that the engineering world started doing is we started going out and actually capturing this information with these scanners. The interesting thing that's happened over time is now I can share this information with stakeholders involved in the project. This is probably over this is probably over about 10 million points of data. I think 10 years ago, I would tell you if I'm gonna share a point cloud with you, I would have to have given you a hard drive and say, here is your data. Now I can easily push it out to these cloud services, and just with an email and a login, you have access to the same thing. Not only did I give you access to everything out on site, the existing conditions, but I'm also giving you a 3D panoramic image of that, and that's my pretty face there in the model right there. Not only am I giving you a 3D point cloud of it, I'm also giving you a 3D panoramic of it, a high definition image of it. So it's really useful for our folks to see this in context. One, this site's in San Diego, so our folks don't have to travel to San Diego to go out and look at these models that we're generating. This is a model based on the point cloud that we generated, and it stitched the images together. So now they can basically walk around this existing infrastructure and see a lot of the information. Where do we have room? Can we get access to it? Can we put our pump there? A lot of that, it was really difficult back 20 years ago because we had to hand measure, we had to go write stuff. The surveyor doing conventional survey would be a little tricky because he doesn't know what we're doing. He's just capturing the information. So now it's on us. Like this type of technology, you're gonna hear a lot of reality capture. This is reality capture because we're actually capturing the existing conditions, and now I can share with my entire design team. I can give them a link. I don't have to give them a terabyte of data. They can go up there on the cloud service, log in. Now they got access to that same model. On the same token, drone data has been increasingly. If you're a Part 107 certified drone pilot, I took my test here at TCC somewhere. I'm 107 certified, so I get to go out and scan some of these sites myself. I love getting out of the office after 30 years of sitting at that desk. Going to West Texas to capture some of this information is a great thing for me. So having that Part 107 took a little convincing to our folks that, hey, I know how to do this and we could do it. But now, not only are we capturing the virtual reality portion of our sites, we're also taking terrain data and extracting it from there. We're taking large-scale models. Because our stuff is so sophisticated and it fits inside these areas, we need to know a lot of information to make our models work. So anything we can do to increase the efficiency, which this typically would take a surveyor weeks to do, and this was 3 days of work for me to capture that information. So that's how efficient the tools have gotten. Your skill set needs to be there too, the skill set, right? Learning some of this stuff, but it's part of the process. The other thing that you don't see in the background that I didn't mention earlier, inside the game engines, there's a little bit of coding. If you ever take a class of coding, it's either C++ or Python, don't lose it. Keep on doing it, because that part is going to come into every part of the industry that we're in right now. It doesn't really matter what discipline you're in. Coding, Python, HTML, JavaScripting, all that is a plus. All that is you know how to work, you know how to make these tools do these things, and that's a plus in the industry. And I think with that, I'm going to pass it to Austin. Austin's got a little bit, because I wanted Austin to kind of tell his story, because it's really similar. You know, he went to junior college, and then he went to Sam Houston, right? So I wanted him to tell a little bit about his story and how he's got to work on some of these projects at Kimley-Horn. I'll help you with it.
All right, so I'm going to start just talking about kind of when I realized that I wanted to do this. I had first kind of thought I want to do civil engineering. In high school, I was lucky enough to have some classes over SolidWorks, 3D modeling, and some drafting. And from that point, I kind of started to look at schools and learn more about what the day-to-day was. And I kind of learned that it wasn't the plan making, drafting, and designing like I was hoping. So I kind of shifted it first to, I found a degree at Sam Houston State University, design engineering or engineering design. And that was kind of more heavily with 3D modeling and 3D printing in that kind of realm, using Revit, which you talked about earlier, and a simpler version of Civil 3D, which is AutoCAD. So those really are the main things I knew going into this, but it was a good foundation for going forward with that. So those are kind of, if you have the ability to take AutoCAD, I'll say it again, AutoCAD, Revit, and some kind of SolidWorks class, or even learn them on YouTube, because when I don't know a lot of answers, surprisingly, I go to YouTube or Google, and everyone else has had that problem. So luckily, you can almost learn it by yourself if you're really determined. And kind of what I have on the screen here is kind of just the split in the day-to-day roles of what a CAD designer does and engineer. And kind of at first, that's why I was a little confused about what an engineer did, is that back in the day, how he showed the people hand drawing it, they used to do both. They were in charge of the drafting and all the calculations, spec reports, and client relations. But ever since AutoCAD came out, it was a big split, and how he showed of all the things we have now, it just slowly built up. So it became too much for one person to realistically do it to the best of their ability. So that's when CAD designer role was created. And kind of what I have on here for engineers coordinating with clients, subs, and contractors, project management of task and money during all phases of design, and creating detailed reports and spec books. I mean, that's what John does. He came here with us today, and he's been doing that for a long time. So he probably speak a little better on that. I wasn't too great about what to put down. Even what I put down for CAD designer does not include everything we do.
Tell him the story. So day one, he comes into the office. We ask him to do a spec book. Tell him the story.
I don't want to do that. I kind of started in the role since my degree was a bachelor's. It was a little bit more than what most CAD people coming into Kimley-Horn had, so they put me on that engineering ladder, and I went with it for a while and just doing what I needed to do, doing what was asked of me. And then it became a point where I realized that if I was going to do this forever, that I need to make a switch. And working with Juan, I'm lucky enough to work with Juan, and the stuff I'm about to show, I didn't know just about any of it last summer when I graduated. I knew the basics. I knew 3D modeling, 3D printing, and some basics, Navisworks he talked about earlier, but that was enough foundation to kind of know what I know now. Okay, so with the first thing I have on the screen right here is one of the first projects I started on when I got to Kimley-Horn. This is a treatment facility, one of the smaller ones, kind of west of Fort Worth on Possum Kingdom Lake. And my task was for the yard piping. So you see all the different kind of interconnecting lines on the northwest part of the treatment plant. And that was the first thing I even learned about water, because I came into it with just strictly a design degree, and I kind of had to learn the basics from water. And an example is right here. For the longest line we had on this project was from a floating pump station that drew the raw water to the treatment plant over kind of a hilly terrain. The project was called the Cliffs, and that's where they got it from, I guess. And then the next picture is one of these shorter lines coming from the ground storage tank to the treatment plant itself. So there's a bunch of them going back and forth and crossing over other ones. So you have to take those into account. And, I guess looking at this, you'd be like, why didn't you just put it deeper? But that's the thing we have to take into account too while we're doing design. Be more efficient is you have to think about how much it's going to cost and the reality of being able to do this out here. So that is just one of the first projects I worked on, and I talked about the pump station that the long line pulls us from. Kind of CAD and Revit, we don't just use one on a project. Majority of the time, they go together, where this is one of the first things I modeled in Revit when I got to Kimley-Horn, is this is going to be floating on the water. It has 2 pumps that draw the water from under it, and then it goes to the onshore line that I showed before. And then the next one, how they work together, is you see where the buoys are connecting at the end. That is the Revit model. I exported the line work using different plan views, and then we're able to bring that in CAD and use it for this visual where we're showing the amount of buoys that will be connecting to it, the low and high points of that lake, and the historical of it, so we know how long that line needs to be and what to take into account for it. The next thing is going to be this video I made using InfoWorks. One of the first ones I had used, if it'll load, there we go. So today, just watching this, I put this in here because I haven't made one yet for a project, but I could do this so much better. Just from it being a year ago, I have learned a lot more from Juan about how to get better surfaces in here. We're using aerial images just from a map called Near Map, and that tank, I just kind of made it real fast as a representation because we hadn't made it yet. And then you could see on the left, that is going to be the proposed treatment plant. And then on the right, and the white tanks in the back, those are the existing stuff. So I kind of just created this, and the purpose we're trying to use them more in the future is to be able, for marketing purposes or after the fact, where these PMs can take these visuals and kind of showcase their projects. Because this project, it was started before I even got there, and then it just finished design, and then we found out the client does not have money to build it. So it'll be a while. So this visual is the best thing that will exist for a little bit. And then this one is also made in InfoWorks. This is more recent case where we had a pump station right there on the right, and then the big tank behind it, and the client was kind of deciding where they should put the logo. And we told them that it should, yeah, they said we want it in the front because that makes the most sense. Our PM came to me and said, we want to create a visualization to show them that that's not going to be the best case, because to the right of this is a school and everyone's going down this way, so they're not going to be able to see the branding on it. So we showed them this one, and they were like, wow, y'all are right. And so this worked its purpose. And like the other project, this one is going to be a timeline animation that using Navisworks. It's a really good visualization tool. It's a little bit similar to InfoWorks, but we can create schedules with what's going to go in the ground at what point. At the top left, you can see there's the day, week, and the time, and the day of the week on there. So this is also a very rough one of my first times doing it. But so I was just kind of roughly assuming what would go in first and applying times to this and dates in Excel, and then I was able to bring that information to Navisworks and kind of apply the objects from Revit to different points on the Excel. So you see that one's a little bit longer because it's going to take longer for them to build the structure than it is going to be for them to maybe put one of the lines in the ground. And then you have kind of the sequencing. I talked with one of our young engineers about what might be put in first, and kind of could potentially show a contractor of the idea of how maybe things will get delivered, how things are coming in, and just the best flow we think for that. Next, this is a more recent one. With the more time I've been there, I got the ability to work on a Revit project for myself for a lift station. So this is a residential lift station. Pretty much, you flush a toilet, it all goes somewhere. This is where it goes. And then it takes it to a treatment plant. So pretty much it's going to come into this. I mean, you can't tell. That's why the visualization we talked about is great, because that's an 8-foot, what we call wet well on the left. That's 8 feet wide and about 40 feet deep. But you can't tell that just from the picture right here. So the things we use with Juan are a little bit easier to visualize that. And then on the right, you can see, like, in the plans, we're starting to use these 3D models more. We use the 3D models to make these flat angles, images from different directions or however we want it, but also incorporating the 3D into it. And we can kind of show a little bit more of what's going on, maybe if you didn't get from the first one. And then the next thing is going to be this, but on a larger scale. This one is going to be for more houses and a larger development. And it's just another example of how we're using we're designing in 3D, but it's still being used for that 2D aspect. So it's similar, and this one right here is the same thing. We're using 3D models on the top and bottom just to kind of better show these views and kind of help with the contractor for understanding it, for seeing it for the first time. And then I think that is it. Are you ready? You're not ready?
One of the things that we were trying to do is process the data. So what I did is I scanned all of you guys with that scanner at the beginning, and my machine is still cranking on processing it. What I was gonna try to do is kind of capture at the end and show you guys the actual model and the point cloud that was generated. So if it's pops up before we end up with the questions, I'll bring it up. So if anybody has any questions.
Jeremy's got the mic. And if you ask a question, I'll also bring you a gift.
Okay, 2 questions. Number 1, with the photo, can we keep it? Like, like take a photo of it and be like, have it as like screensaver?
Which photo? The one from the scanner?
Yeah, from the scanner.
Yeah. I can extract it. Yeah, I can extract it for you.
Oh my gosh, that'd be so awesome.
Yeah. I just gave myself a lot of work. Hopefully not so many of you guys want it. But yeah, I can extract it.
Beautiful. The second question is regarding to using AI split sections to be able to actually help with the development plan. Do you guys actually use that as a way to aid new ideas, or is it mostly kind of a gray area?
That's a great question. We're having internal discussions as we speak about how AI is affecting the engineering world. I mean, I couldn't even have stated that question any better. I go in, the engineers come and ask me, Juan, how is AI going to affect the engineering world? It's a little tricky, right? Because you have to be careful about the way you answer that question. Look, you guys are our college students. You guys have seen AI work, right? AI doesn't work unless you don't share that knowledge. Right now, AI is in its dummy infant stages, right? And it's in its baby steps right now. It's in its infant stage. So everything that it's spitting out, it's still not 100% correct, right? But the only way it gets better is if we teach it some of that information. That's a little tricky in the engineering world because it's proprietary information. We don't like sharing our design. So what's that leading us to come up with? And this is big story, big picture, right? A lot of these firms are going to generate their own interior tool. Not because they want to, it's because we want to teach it to do things our way and do things that we want and not share with another engineering firm. And I think that question, I mean, it's happening right now. It's only going to increase what you just saw. The things that you just saw right now are only going to get better, more realistic. We're going to get a lot more from the models because AI is going to help us develop that content. That's a great question.
Hi there, Juan. My question for you is, it seems that Kimley-Horn is more civil engineering. How do you operate with other related engineering branches?
Yeah, we deal with a lot of subs. We actually just started a practice, an MEP practice at our firm. We got a solar practice. I mean, we have multidiscipline practices at Kimley-Horn. So it's really intuitive for us to make sure that we use these tools, not just for our platform, but for a lot of them. So a lot of those subs, they're asking for this information right now. So we're multi-platform. I mean, we have LAs. We don't have architects, but we have landscape architects in our engineering company. But we don't have architects. That's the only thing we don't have. Engineers, designers, LAs. We have analysts, GIS analysts. We have a plethora of folks that are doing different things in the firm. Go ahead.
kind of like, since we pretty much do everything except architecture, but we still work with them a lot, like the pump stations you showed and different things like that, like we have to coordinate with them to get those done. So with like InfraWorks or Navisworks, like I've had multiple cases where when he's out, they come to me. So that's a lot of pressure. So with Navisworks, we had an architect that said, we need to compare y'all's surface and different pipes in the ground for a large warehouse. And they weren't sure if everything was lining up, everyone's in the same coordinate, same elevation. And then I brought it in there and realized that architecture's was very off. So kind of coordinate with that is everything was not in the same coordinate systems, elevations, and that would have had inconsistency between our plans. So we don't do, as you were saying, we don't do everything in a way with architecture, but we still work with any kind of subcontractor.
How does that sounds like there would be a lot of non-compliances with because if the measurements are off, are you sending the designs to the architect in order to have that functioned out to blueprints?
For like the cases of like the pump stations, we're usually at the prime on the project. So in that case, the architect was like, oh, move your surface and move your pipes. But that's a lot more than kind of just clicking a whole building and moving it to a different place. So in that case, I was like, it's going to be a lot more time efficient for them to move their stuff to our place. And that was the ultimate fix to it in the end.
Okay, and I haven't gotten to your level of CADing, but do you guys ever use hands-on modeling, or is it all being replaced by VR and AR modeling?
We haven't done too much of the AR, VR in like a practical sense of when we're modeling, and Revit is the majority of the way that we do 3D modeling. Like I learned Creo, SolidWorks, and some AutoCAD has ability for 3D. But does that answer your question, like in the sense of modeling what we use, or?
Yeah, like
oh, okay.
You know, when you start off as a student, you model the structures in order to see the balances and to see it in like real life. You know, if you go to a museum and you'll see the structure of the building inside.
Yeah, so that we work with our architects and partners. I mean, we don't modify any of their work. Right? They send us that information, and remember I was talking about the Legos? That's a part of the Lego. Yeah. If an architect says, here's the pump room that I'm giving you so you can put it in your model, we're only taking the facade and assembling it with our pump information or with our motor information, right? All of that is conjunction, and so it's all kind of with our subs, and it all correlates with each other. But that's why the project coordination is a big one on these projects, because a lot of it is coordination on our part. We don't do everything on our projects. I mean, there's some electrical subs that are coming into play, architects that come, landscape guys that come into play. So it's for us to, if we're the prime, we want to make sure our project looks good. So we want all of that information from our subs to get put into these models immediately. So
kind of on this one, for when we do the initial design, like we're putting everything in here, but when it gets to a certain point, like the walls, the foundation, we're sending our model to structural, and then they're sending back pretty much just walls. And all the pipes in between, like that's up to us. So there's a lot of coordination with Revit to make sure that we're in the same place or their walls won't show up in the same place. So it's not as much as physical models as it is kind of how we're showing that everything's going to digital.
That's awesome. And I don't want to hog all the time. Final question. So 10 years in a row, you guys have been Fortune 100, sorry, I'm so nervous. Fortune 100, sorry, I'm
top 100 companies to work for.
Sorry.
No worries.
You see a lot of young faces. How does that impact Kimley-Horn?
Yeah, that's a great question. We see a lot of the information, and we see young folks wanting to work at Kimley-Horn, because I think even we were ranked number 10 for the youngest. I forget exactly what the wording is, but there's a lot of folks that want to work at Kimley-Horn, and I hope it's to do this stuff, right? But a big portion of what we do at Kimley-Horn is train our young engineers to do some of this work. That's where I come in. I get to do a lot of this cool stuff, but I also have to teach and develop these younger folks that want to come do this type of work, right? Austin, at some points, he's already helping training these guys, but young people want to work at Kimley-Horn. It's a great place to work. I get to do this kind of stuff. This is awesome for young folks to see and want to strive to do.
But how does that impact your operations?
I mean, it's a business plan. It's a model that we have, and we've used it for a long time. We hire a lot of young folks. We do. We're not stacked at the top, right? Guys like John that have been in the industry for 30 years and have been in the engineering world for that long. There's 2 of us in a group of 250 or something. There's more folks like me and Austin there than there is John's, because I want to say 80% of our staff is young engineers. Yeah, but I will say that I've worked at other places, and I got to Kimley-Horn and I complained to the guy who recruited me, why didn't he get me there sooner? Because it's an awesome place to work, and I could tell you that the folks that work there are great to work with, and they have the way we describe it is we have a business environment, but we're just engineers, right? That we're strive to do best for our clients. So it's a great place to work for young folks and capture that background.
Do you offer internships for students at community colleges?
That's kind of how I started. I started off, I was living around Houston, and then I was kind of just applying to everything I could because I was graduating the summer and I needed an internship to graduate. And pretty quickly, Kimley-Horn reached out to me and I had an interview the next afternoon. Super scary because I hadn't had that many at that point. But I got lucky enough that, they liked my qualifications. And like I said, I had never learned about anything water when it came to in school. But just showing that drive to want to learn new things really gave me the ability to start off in Austin and in the developmental services department. And when that didn't work out, they didn't have the space for time and hiring right there. Kimley-Horn's big thing is instead of just, oh, sorry, we couldn't, Juan had remembered about me and kind of shifted me up to Fort Worth. I'd never been to Fort Worth in my life. I thought it was just the same as Dallas. It's not.
But here's the story behind that. If I hadn't met Austin and he didn't ever tell me, Juan, I have this 3-dimensional mindset, I never would have wanted it on my team. Because the stuff we're doing is driving the content we're putting together. I don't necessarily need you to know everything about what we're doing because I can show you and train you that, but I need you to have that mindset, right? Anytime you get in front of SolidWorks, anytime you get in front of CAD tools that are 3-dimensional, anytime you get in front of Inventor, take those things, take them, learn them, and I could tell you right now, in 30 years, it'd still be paying your mortgage if you master those tools.
And kind of just going off, you said, do they take internships from community colleges? I want to raise the hands of who's heard of Sam Houston State. That was more than I ever expected. No one really has heard about the school I went to before, but that didn't really matter. It just kind of matters what you do in the office, what you provide, and kind of what you bring. And even if you come and you don't know everything like I did, everyone, not just Juan, is willing to help you get there as long as you have that same drive.
Testing. So I got here a bit late due to some testing, so apologies about that. But my parents both are actually civil engineers in a nearby engineering firm. I heard communication between producers and engineers, they can either be your best friend or greatest enemy.
Yeah. Very much. Very true.
I kind of want to piggyback on the internship question. What kind of skills and things kind of make somebody stand out, or do you look for when you're going through and sifting through the internship applications?
I could tell you that over years, this has increased, that skill set or that knowledge, because it used to be, if you didn't have this, we probably wouldn't hire you, right? But I think now, even with Austin, he had that 3D mindset. I don't care what tool you've used. If you have that understanding of the modeling world, or if you know some scripting or Python, I'm immediately drawn to you because we're embedding those things in these engineering plans right now. And that's something that we're going to grow internally at Kimley-Horn too. That's one of the things that I think at some point you're going to see a lot of engineering firms developing their own tools. So you got to have that little bit of background of the coding knowledge, and how does it affect the tools that we're using right now. In 10 years, it could be something totally different, but I could tell you that the things that I've learned over the times, it's still CAD driven. Everything is still a byproduct of the geometry and the math and the trig and all of the same stuff that you're learning, and you say, I'm never going to use that. You're probably not going to use it day to day, but it's still geometry driven, a triangle, what's a radius, what diameter, the area, the square footage. All of those things are still being used today. It's just now that $200 calculator now costs $10,000 because it's putting these models together for you. So that's how my engineers always like, hey, Juan, I don't want to get there that quick because you're making it too fast. Well, remember when you used to have 2 + 2 = 4, then the calculator came along, you're like, oh man, 2 + 2 is 4. I got that so much faster. That's all my machine is doing. It's just getting to the end result a lot quicker now.
Test. I'm going to be lazy here and piggyback even more. Outside of the workplace skills and all of the 3D modeling skills that you need to work in that kind of environment, what kind of actual workplace skills would you say someone you would be looking for in someone like an intern?
Well, I gotta want to work with you first of all, right? We interview our staff all the time. That's one of the things that we do at Kimley-Horn. It's a different model, than most folks. Austin's going to interview a hire here next week sometime. He's going to help us interview. He's a year in at Kimley-Horn, but he's going to help us decide if we can hire this person to come work with us, right? It's a group environment. We're all part of it. So if the team says, he has the skills, but, he has a little bit, he has trouble with this, and this, those are all things that he has input in. So if he wants to work with them, he has the skill set, they'll hire you. That's part of the interviewing process there at Kimley-Horn. We make it to where these guys can help us make those decisions. You want to talk a little bit about that?
Yeah, I guess kind of what I've told my friends that are coming out of college after me, it's not really always what you know. It's kind of, you got to sell yourself some. Like how I had interned, they pulled something up on the screen when I was interning, or when I was interviewing, and I had not seen it before. But instantly I was just trying to dig into it and see what it was and kind of relate to it or say, hey, I haven't seen that before, but I'm willing to learn that, and I think I can. So it's kind of, you don't always have to know everything. Like I said earlier, it's like I didn't know pretty much all of this stuff last summer, but just kind of digging into the weeds and learning it slowly. And kind of what he said about the office environment is, I am not always the most social person, but definitely at Kimley-Horn, they make the ability for that to happen. Like, it's pretty much sometimes my own fault if I'm not going out there and talking with my coworkers and getting to know them more, because that kind of helps us work as a team even faster and more efficient. That's the thing I'm slowly starting to get better at and learn the benefit of it. So it's not for everybody in a way of like, not I said that terribly, but kind of in the way of, you go into a new place and you expect that you have to be doing everything right the first time, and that, you're allowed to make small mistakes. Those are going to happen as long as you're, know the people around you and honest about it.
I had a quick question. I'm engulfing myself in 3D design, 3D modeling a little bit, but I have what is it called? I don't know why I got a brain fart. A MacBook Pro. And it just sucks, man. Like, I'm just modeling an R2-D2 and it just turns off, and it just really sucks. But what laptop do you recommend that's affordable for college students to start learning 3D modeling?
Get with me after we can talk.
I can't think of the name of it. It's like Nexus, something like that. I had that laptop all through college, and I don't know how it did not explode.
Yeah, because everybody's telling me like Windows.
MacBook,
Yeah,
terrible.
Yeah,
I know
it's
that
horrible,
it's
man.
not. It's
Like,
not good. So definitely, it's not anything with Windows, and I think it's like the i9 or i8 kind of Intel cores. It'll work out.
We can geek out about hardware after the class, but I will quick plug for, so a lot of these tools come from our license agreement, the software agreements that we have in place with Autodesk. If you're a college student with a .edu extension, they will give you these tools. They want you guys to have these tools free. So you can go home and download all of this stuff that I just showed you and reproduce your own stuff and your own content at home. If you have a .edu extension, you can sign up and trial these tools immediately. So I don't have any stock in the company. It's been paying my mortgage for 30 years. So it's really interesting when I tell young folks about that. They're like, shoot, I didn't know. If I was young and I had that, I would download all of their library and just go to town on it.
Real quick, I want to go ahead and close us out because it is time to be done. But the guys have said they'll stick around. So if you still have questions that you want answered, you can come talk to them individually for sure. So yeah, let's give them a round of applause.